Alright, so last week in class, we looked at how we can use our quadratic equations to come up with functions of these examples of our Angry Birds when it comes to quadratics. So we've got our parabolas, which are showing the path that the birds would travel. And you can see there's three different paths here. The red bird, the yellow bird, and the blue bird. I believe red bird is the red on here, so the higher one comes down. I believe yellow, I want to say, is the in-betweener, and our blue was the most narrow. We worked on finding these without using Desmos, but here's an example of what they would look like in Desmos. We said that we had a pig at 5, and 10, 5. So we could see that one of those birds did hit each one of those. So this would be a very simple level or a very simple example of kind of our Angry Birds situation. Now, what you guys are going to do today while I'm out, and we'll talk about it a little bit more on Tuesday, is you're going to create a piecewise function that allows us to add a couple more elements to this Angry Bird game, this Angry Bird experience. Now, you guys have played Angry Birds, most of you have, so you understand that there's different attributes for different birds. Now, I know some of the birds, they just travel in their parabola and they land wherever they land. Some of the birds, you can click on them and they speed up. Some of them you can click on and they break off into 3 different birds. Some of them you can click on and they explode. So there's a bunch of different things that we can bring into this now, which is exactly what I want you guys to do. Today, you guys individually are going to be creating a level for Angry Birds. So it could look anything like what I have here, or you can make it as in-depth as you want. But mathematically, I want it to work out. So I want it to start with at least a parabola. So if I go in and use Desmos if you want to, that's what I used, and it makes life a lot easier. If we go in here, and let's see if I can bring this over so we can see what I'm working with. If we go in here, this is how I would set up my level. First, I would say that this 5-2, this 5-2 here would be the bird that I'm trying to hit. And then I would say this is going to be the path of the bird I'm launching. Or I'm sorry, the pig I'm hitting is at 5-2. The bird I'm launching is this red line. Obviously, you can see with this, the way this parabola is with the arc, it's not going to hit, right? It's going to land a little bit short. There's no way it's going to hit that. So what I have to do is I have to decide how long can I travel this parabola before I can click on my bird and it'll hit that spot. Now, when I click on my bird, I've decided it's going to change it to have a function or a slope that looks like this. So the slope's going to be -1/2x plus 4.5. So the slope's going to be -1/2. The plus 4/5 is just for graphing purposes. If it would go all the way through, that means it would have a y-intercept at 4.5, but I'm not worried about that. But what we can see here is where those two intersect. That is where I want to click my bird. So if I go from 0 to 5, so those are my parameters from 0 to 5, you can see this function starts at 4.5, goes all the way down, and eventually it will hit that bird. Now, actually, I could click on my bird at 2 different spots for this one. I could click on it, that initial one where it crosses, or that secondary one. I'm going to focus on the secondary one. And the piecewise part is what we're going to talk about a little bit more tomorrow in class. But this piecewise part is telling it how long do I want that function to exist. So my bird's flight, the first 2.43 seconds are going to be mimicked by this quadratic function up here. Okay, that's what. So from 0 to 2.43 seconds, it's going to be mimicked by this quadratic equation. Now, at 2.43 seconds, I want to click on my bird which means it's now going to be following this equation here. So from 2.4, and I should make that 2.43 so it lines up perfectly. So from 2.43 to 5 seconds, it's going to travel on that second path. And you can see if I use this and I go from negative 2x squared plus 5x plus 3 up until that 2.43 seconds, and then I click on my bird and it follows that second function, I'm going to hit that pig. And this is just a piecewise function because it's taking a piece of this function for a little bit of time, and then it's combining it with a piece of this function. So what I want you guys to do today, individually, I want each of you to come up with some sort of function, piecewise function, that'll be a level in AngryBirds. So this is my level, pretty simple, a little bit more complex than the ones we were working on yesterday, but it's still pretty simple in the way that it works. Now, if you want, you can make it so that when you press the bird, it explodes. If you want to do that, let's see if we can get a good idea of what that function would look like. It would be, let's say, we want it to be at 4 in the x, and we'll go with 3 in the y. So if I'm talking about a circle, let's see if I can graph it on here. Oh, there we go. So if I'm talking about a circle here, now I could say at this point in the center of my circle, which is 4, 3, so 4, 3, as long as I can find some sort of function that'll get my bird to 4, 3, if I click my bird there, you can see that explosion radius, since that pig is inside the radius, that counts as hitting the pig. Now, I want you guys to be creative with it. I want you to come up with whatever you think you can come up with. We're going to talk about these on Tuesday, but I want you to at least have something started, something written down. I want to see some functions that we were thinking about using. So think about it. Think about what would make kind of an exciting level. What kind of functions you can use. Can I use quadratic? Should I use linear? Is there a way I can use exponential? Is there some sort of way that I want to jump into using the equation of a circle to get ready for next year in geometry? Challenge yourself. See what you can come up with. I'm looking forward to seeing what you guys come up with for tomorrow.